In this video, I'm going to solve the 8th problem in the assignment 4, which is finding the kth smallest element in the array. So we have given an input array here and we need to find the kth smallest element. So in this array, 7 is the third smallest element in this array. So the output is 7. To solve this problem, one way is to we can sort the array using quicksort, which will be the time complexity of n log n, and we do not need any extra space for that. So the space complexity would be big of 1. But in order to reduce the time complexity, and I'm gonna use the Maxheap. So first I'll implement the Maxheap and then I'll be explaining the with the example. For implementing the Maxheap, first I'm gonna write the class for Maxheap, and in order to take the parameters, I'm gonna use the constructor which takes in array and size. So I'm assuming A as the array, and k size is the number of elements that we are gonna implement the Maxheap for. I'm writing few variables, and so I'm declaring I. In the I, I'm going to take the leftmost child of the array with size, with the given size. So this will be math.floor this dot heap size -1/2. So this is the leftmost child of the array with size, with the given size. While I greater than or equals to 0, this dot max heapify of I. I'm using this while loop in order to in order to sort the array using the max heapify function, which we are going to write in some time. So I'm writing some functions here. So in order to get the parent of element I, we need to do I-1/2. To get the left child of a node, we need to do 2 into I plus 1. Same for the right child, except we need to do 2 into I plus 2. In order to get the max element, we just need to return the element at index 0. So this dot h array of 0. Replace max. So if we want to replace the element at index 0, then we need to do this dot h array of 0 equals to x, the given element, the given number. Then we need to do the Maxheapify so that it will be sorted. Now let's write the Maxheapify function. Maxheapify let's assume L as the index of the left child of I. So to get the left child, we have written the function left of I. To access that, we can write this dot left of I. Now let's declare R equals to this dot right of I, and I'm assuming the variable largest equals to I. Now if L is less than this dot heap size, so L is the left child of the given element and R is the right child. So if L is less than the heap size that we have given, and if the element at index L is greater than the element at index I, then we are going to change the largest to L. Then we are going to check with the right index, so which is R, if R is less than the heap size. We need to check this because we are just the array size can be more than the heap size, but we are doing the Maxheapify for only the number of elements that is declared as size. So we are checking R is less than the heap size, and this dot, so the element at index R is greater than the element at index I. If that is element at index not I but the largest. If that is true, then we are going to change the largest to R. Now we are going to check if largest is not equals to I, that means we have changed the largest, which means the largest has become the the left child or the right child. Then we need to swap those elements. So let's assume a variable called temp, in which we are going to store the element at index I, and then we are going to swap the elements at index I with the element at the largest. So in the largest we have the index of the element which is largest. So if left child is largest, then in the largest we have the index of the left child. Otherwise, if right child is greater, then we have the element in the right child. The index of the right child in the largest. So we are going to swap them. Once we swap those elements, then we need to do the max heapify again for largest element, largest index. So this is the code for max heapification. So if we give the array and size number of elements that we need in the max heap, then we can do the max heapification. Now for our problem, we will write the code to get the kth smallest element using this max heap. So for that, I'm gonna write a function. Kth smallest. So the parameters are array and k. These are the inputs that will be given for us, and let mh equals to new max heap of array comma k. So here we are defining the max heap in the variable mh, and we are giving the array and k as the inputs. Now we'll loop through the array from element k. Let I equals to k, I less than n. I less than array dot length I plus plus. If array of I is less than mh of getMax. So getMax function gives the element at the index 0 after doing the after the max heapify, which means the largest element in the after doing the heapification. If the array of I is smaller, then we are going to replace it. So replace max of array of I. So we are going to replace the max element which is the root element with array of I. Then after the for loop is finished, we are just gonna return max element. So this is the code to get the kth smallest element. Now let me explain this with an example. Let's take this given example. So 7, 10, 4, 3, 20 and 15, and k is 3. First let's see the kth smallest function. Here what we are doing is in the variable mh we are we are defining the max heap. So for the max heap, we are giving the inputs this array, and k is 3. So let's go to the max heap. In the constructor, we have the parameters as this array, and the size is 3. Now H array is the given array, and heap size is 3, and I equals to math.floor of this dot heap size minus 1. Heap size is 3. 3 minus 1 by 2, which is 2 by 2, 1. So this will be the leftmost child when there are 3 elements. So while I greater than or equals to 0, so here the I is 1. 1 is greater than 0, so we need to do max heapify of I. So let's go to the max heapify function. In the max heapify, what we are doing is in the variable L, we are storing the left child of I. So the I is 1. I equals to 1. So L equals to left child is 2 into I plus 1, which becomes 3, and the right child is 4. And in the largest, we are storing I, which is 1. Now if L, which is 3, if 3 is less than heap size is 3, so this is not satisfied. It does not go into this this method. Now let's check this one. If R is less than the heap size, R is 4 here. 4 is not less than the heap size 3, so it does not enter into this method. And here we have if a largest is not equals to I. We did not change the largest, so largest equals to 1, which is I. Now what happens is it gets back to this while, and the I becomes decremented. I is equals to I minus 1. Now we need to do again this dot max heapify of 0. Now L becomes, so the L becomes 2 into 0 plus 1, which is 1. R becomes 2. 2 into 0 plus 2 becomes 2. And largest is 0. Then we'll check if L is less than heap size. So the L here is 1. 1 is less than 3. This is right. And this dot H array of L. So L is 1. In the array at index 1 we have 10. 10 is greater than H array of I. So I is 0, which is 7. So this condition also satisfies. Then the largest becomes L, which is 1. And now let's see the the next if condition. So right is 2. 2 is less than 3. This one satisfies. And if H array of R is 2. At 2 we have 4. So 4 is greater than this dot H array of largest. In largest we have 1, so at 1 we have 10, so this one does not satisfy. Hence we have in the largest we have 1. Now we'll check if largest is not equals to I. So I is 0 here, so I is 0 and largest is 1. These are not equal, so we need to swap those elements. So in the temp we have H array of I is 0, so element at 0 is 7, and we swap the element at 0 which is 7 with the element at largest is 1, so we swap these two elements. So the array becomes 10, 7, 4, 3, 20 and 15. Then we need to again do this dot max heapify of largest. Largest is 1. So we already did the max heapify for 1, and the left and right child becomes 3 and 4, which are greater than the heap size. So it does not change anything. Now let's get back here, and so that is all for this one. Here in the MH we get the array like this. Then we do this for loop from I is equals to k. So k is 3. At index 3 we have 3, and if array of I, so array of I is 3, the element we have is 3 is less than mh, this is the dot get max. In the get max function we get the root of the element or the element at index 0, so which is index 0 is 10, 3 is less than 10, so we are going to replace the max. So to replace the max, what we are going to do here is we are gonna replace h array of 0 with x. So we are going to replace x is 3 here, which is array of I. So the array becomes 3, 7, 4, 3, 20 and 15. So the array becomes like this, and we need to perform the max heapify of 0. Because we changed the element at 0, we need to perform the max heapify again. So max heapify of 0, here L equals to this dot left of I, which becomes 1. 2 into 0 plus 1 is 1, and the right becomes 2. Then largest is 0. Then we are going to check the conditions if L is less than heap size. So L is 1 less than 3, which is right. And the next condition is this dot h array of L. So element at index L is 7, greater than element at index I is 3. This is this condition also satisfies, so the largest becomes 1. And then we check this condition. If R is less than heap size, R is 2, this is less than 3, then we check this condition, which is this dot h array of R. So R is 2, at 2 we have 4, greater than this dot h array of I. H array of I is 3. We need to check the array with at index largest. So the element will be 7. 4 is not greater than 7, so this one does not satisfy. So in the largest we'll have 1, and we get to this condition where largest is not equal to I. So in the largest we have 1 and I is 0. So we need to swap the two elements. So now the array becomes, we need to swap the element at I, which is 0, and at element largest, which is 1. So the array becomes 7, 3, 4, 3, 20 and 15. Then here k is incremented and k becomes 4. Currently k is at 3. So after in the next step k becomes 4. So at array of 4 we have 20. So 20 is not less than max element is the element at index 0, which is 7. This does not satisfy, so the I is incremented, so I becomes 5. So array of 5 is 15. So 15 is not less than 7, so it does not satisfy the condition. Then we will get out of this for loop, and we are going to return mh.getMax. So in the getMax function we will be returning the element at index 0. So 7 is returned. So 7 is our output. If we see the given element, given array, first input array, and the k is 3. So the third smallest element here is, if we see here, 7 is the third smallest element, and finally we got the answer 7 as our output. Thank you.